In the previous video, we discussed about how to, prove that the particular solution actually is the solution for differential equation or not, correct? Now, in this video, we are going to see how we can frame a differential equation from the given equation. Okay. Now, let's start with a very simple example, that is equation of a line. Now, we all know that equation of a line is y is equal to mx plus c, correct? We all know this one. So y is equal to mx plus c. What does it basically indicate? We have a line, see, x-axis, y-axis, right? Say in this one, the line is going something like this. So say the line is going something like this. Y is equal to mx plus c. Now what we know here is there are two important parameters, correct? You can say there are two important constants or arbitrary values. You can call it however you want. What are those two values? The first one is the slope of the graph. Slope is nothing but the angle what it makes with the x-axis, correct? The second parameter is the y-intercept, which is this value c. So this distance is c and the slope is basically m. Now these are the two constants what we have in this equation, y is equal to mx plus c. Now whenever we talk about a differential equation or forming a differential equation, remember we have to eliminate these arbitrary constants. The reason is, when you talk about a differential equation, it's not like an algebraic equation where you substitute for x, you substitute for y, solve it, get the value of m and c, right? Now a differential equation is where you integrate and then you are going to get the values, isn't it? Now let's suppose, say we have to find the differential equation. The very first step what you need to do is differentiate. That means if you differentiate this, you get dy by dx is equal to m, isn't it? M is nothing but dy by dx. This you already know. Slope of a line is nothing but the derivative. We take this derivative and we are going to put this in this particular equation. Understood? So what do we get? Y is equal to dy by dx into x plus c. So this is what we are going to get. That means the line equation is nothing but we have a very important parameter, that is the derivative of the function. Derivative of the function into x plus c. Okay. Now what does this particular value indicate? Because if I need to calculate the equation of the line, what do? You integrate, but not definite, indefinite integral. Now when you integrate this one, what you get is not just one line, instead you are going to get family of lines. In the sense, you are going to have a value of m is going to be the same, but c value keeps on changing. Since c value keeps on changing, it's not just this one particular line what we have in the graph here. You can have another line which is parallel to it, another line parallel to it, parallel to it, parallel to it. So it's not one line, it is family of lines, isn't it? So we can say that this equation y is equal to y dash x plus c represents the family of lines having the same slope m, correct? Again I'll tell you, it is the family of lines which has the same slope m. That differential equation is given by this one. See, you just frame a differential equation, correct? So remember, whenever we create a differential equation, what it represents is the family of curves. Now for a line we did it. The same thing can exist for circles, parabolas, conics, any sort of a conic section. hyperbola, ellipse, whatever you have. Understood? So this video talks about how do you frame a differential equation, right? So you have the equation, differentiate, get the value of dy by dx. And once you get the value of dy by dx, substitute that back in the equation and you are going to get the family of curves. Okay, like this you can do it for parabola, you can do it for hyperbola, everything. Now let me show you one more example for circle. All right, so let's do one other simple example for circle now. What is the equation of a circle? See, you have, say, x-axis, y-axis, and we are going to take the center of the circle as the origin. And you are going to draw a circle, assume. Okay, and the radius is, say, r. The equation is what? X square plus y square is equal to r square, right? Differentiate. So before differentiation, I think you can say y square is equal to r square minus x square. Y is equal to root of r minus x square. So y dash or dy by dx 1 by 2 root r square minus x square into minus 2x. 2 and 2 cancels, or dy by dx is equal to minus x by root of r square minus x square. Isn't it? Now we got this value. See, what we need to do is that we need to frame a differential equation, isn't it? Once you have this value, see, what you can do is we don't have this one dy by dx in the equation, right? We neither have this nor we have x or anything, right? We still have that arbitrary constant r, isn't it? We need to get rid of that r. So what do we do now? We have to get rid of it some or the other way, right? We can again differentiate and we can do it, right? So what we'll do now, you can further differentiate it, or you can write dy by dx is equal to minus x divided by y, correct? Now you differentiate this one. Okay, now you can differentiate, you can keep it as it is also. In the sense, you can say this will be y into dy by dx plus x is equal to 0. So you can keep it as it is. This becomes the differential equation. Or family of circles, they have the origin as their center and radius of r. Clear? Now in the next video we will solve few problems, because once you solve problems you will understand it much better. All right, now in the next video let's solve few problems based on whatever the concept we have learned. All right.